Hello again. In the last video, I asked you to try and finish up number 4. I'm hoping that you got these answers right here. X has to be 45, Y has to be 5, and that Z, using the Pythagorean theorem, comes out to the square root of 50, which can be simplified to 5 times the square root of 2. So, let's go forward a little bit. Number 5 is pretty similar. I'm hoping that you get X has to be 45, which tells us this is an isosceles triangle. So whatever this length is here, whatever this length is here, you have to have the same length there. And in order to find that length, you just use the Pythagorean theorem again. So I'm hoping you would set up y squared plus another y squared equals 1 squared, which is just 1. That gives us 2y squared equals 1, which means y squared is 1/2, which means y is the square root of 1/2. I'm going to let you guys do a little bit of work, see if you can remember rationalizing fractions that have radicals in them. This would be the square root of 1 over the square root of 2. We'd multiply both the top and the bottom by the square root of 2, and we would get the square root of 2 over 2. Okay. Number 6. Since all 3 sides are the same, I'm hoping you recognize that that means all 3 angles would be the same. So x and y and z would all be what measure? I think you can handle that much. Going forward, number 7 should look very similar. If this is 60 and this is 60, then whatever this angle is at the top of the triangle, the one large angle right there, I think you can figure out that that one also has to be 60. Let me clean this up. So if that one also has to be 60, then what does that make x? Because it looks as though the left side of the triangle has to be identical to the right side of the triangle. So I think we can determine that x has to be 30 degrees. And I think that based on what we had before, we know that this side right here has to be the same as these two sides, which means y and z must both be, well, together must be 1, which means individually they are 1/2. Okay, moving on to number 8. This should look like the same diagram. As a matter of fact, number 8 is just the diagram for number 7, split in half, and I'm showing you just the right side of it. So if this is 60 and this is 90, then clearly x has to be 30. If the hypotenuse is 1, that corresponds to that side right there. And y is still the y we had in the previous diagram. So y must be 1/2. And if you need to find z, well, we didn't have that measure in the last diagram. So we're going to need to use the Pythagorean theorem, just like above, using 2 side lengths to find the third, except here we don't know we know the hypotenuse. We're not trying to find it. So if you set this up, you will find that you've got y, which is 1/2, squared, plus whatever z is squared, gives you 1 squared, which is 1. So I'm going to do a little bit of math without writing it down because there's not much room. 1 squared is 1. I'm going to subtract the 1/2 squared. 1/2 times 1/2 is 1/4. So I'm going to subtract that 1/4 from both sides, and that gives me z squared equals 3/4, which means that z is equal to the square root of 3 over the square root of 4, which is 2. So I just got z, square root of 3 over 2.